Hello all, welcome back to the session on Agentic AI. So the topic for today is continuation of yesterday's topic plus extra topic. So if you remember yesterday we started with Streamlit. So we are going to do a couple of examples on Streamlit followed by ChromaDB, correct? Yes. So we'll try to understand Streamlit UI integration. Then ChromaDB. Yesterday, if you remember, we learned the example of Streamlit basics, and we also integrated with a agent by using request module, correct? So the first part of today is to integrate it with some advanced agentic systems, correct? So one of the most common agentic system which we use is the database one, correct? So we are trying to integrate Streamlit with that. So if you remember, we have this LangChain, Olama, and then community.utilities SQL database, correct? And we also have toolkits, create SQL agent, and we make use of a Streamlit callback handler, correct? So we are saying set page title as SQL agent with Olama, and we see the caption. Then what I do is I create a sidebar. Inside that sidebar, I have text input, host, username, password, and database, correct? So you can see the text input of password is having a value and its having type equals password, correct? And database name. Now what I do is in the select box, I also allow the user to select which model they want, correct? Llama 3, Mistral. Next, what we do is we make use of this get SQL agent function, which makes use of username, password, host, database, and mode, and we cache it. So it's going to connect to the database. It's going to make use of this chat Olama with the model we have, and we are creating SQL agent, correct? And return agent executor. Okay. Then we make use of get SQL agent. If agent is not able to connect, we will say st.error and st.stop. If not, if messages are present in st.session state, so if a st.session state doesn't store messages, then I am putting a message that I am connected to your MySQL, ask me anything, correct? Then for messages in the same st.session state.message, we chat with the user. So st.stat message is there. Role and whatever write we do, we get the content. We also ask the user to enter something. When the user enters something, that question we take as a prompt, and that prompt is passed st.chat message user dot write prompt. We are writing this prompt. And whenever from the assistant, whatever response we will get, you see st.streamlit callback handler. So whenever the response will come, that response we will show it in st callback, correct? So when I say agent.invoke, when I call this agent.invoke, it will have the input prompt which was entered by the user and the st callback. And whenever the response comes, that response I start printing, correct? And I also append this message in the state so that in future if same question comes, we can easily get it from there and answer. So this is what is the code which we have written for integration of Streamlit with our MySQL agent. If you remember, we did MySQL agent couple of days before. So same code we have used it with Streamlit. Okay. So one of the learning here is we can make use of this chat input. Second is we can also make use of Streamlit callback handler, correct? So using these two things, we will be able to get the response. So if I have to run this, can copy this, Streamlit run, open a command prompt, say CLS and run. I think something went wrong in line number 2. Oh, accidentally, I must have deleted something. And refresh. Yes. So chat with database, you can see host name. I just have to ensure that in Docker desktop, my database is ready. Yes, my database is on. So you see root, password is also root, MyDB and Llama 3. Here we are trying to get the SQL agent with Llama model, Llama 3. So I'm connected to your MySQL database. So I will ask the same question. What is the total quantity of products ordered by Charlie Dev? If you remember the same example we had run couple of days before, please ensure that Llama is also running. So we can copy this, come there to the UI and paste it. And click on this. So now that thinking comes. So this is our callback handler. So it will start showing the steps. So this will run, as you know, running on local, it will take a couple of minutes. It will start showing the response as soon as it starts getting. So let's wait for a minute. Whatever response will come, that response will start showing here. So while this runs, let me go and explain the code once again. So let's see from the top. So we have MySQL host, which is a part of sidebar. We have username, password, database, and name. Correct. Then we make use of this get SQL agent, which makes use of username, password, host, DB name, and model. Correct. So within this, what we do is we make use of SQL database dot from URI. We make use of chart Llama, temperature equals 0 means high consistency, and create SQL agent. Within that, we call this, correct, and return the agent execute. So when we call this get SQL agent, if not agent, if you are not able to connect, we will result in a error. Else what we will do? We check if messages are not present in session state. We know that Streamlit provides session state in which we can store anything. Where I am storing the message that I am in assistance. Now for each of the message, I say chat message, correct? And write in the content. Then what I do? If prompt. So I am asking the user to enter something in the prompt. So when user enters, I will take that message, append it as a prompt, and pass it to st.chat user, correct? Dot write prompt, correct? Then with st.stat message assistant, I am using the Streamlit container. I am calling the prompt, which was entered here, and I am using this callback. So whenever the output starts coming, I will start writing the output, correct? And I am also adding the final answer in messages, correct? If you go and see there, you see it started evaluating. It will show step by step, if you remember. Yes. You see? Yes. It's repeating the steps. And then again. I think first one has still not finished completely, but nevertheless, I ran it again. Let's see what happens. Again, look. Get the data and show the final results. Okay, so whenever the results will come, that results will get printed. Okay, so this is how this integration with Streamlit works. It's a straightforward integration where answers are coming to and fro. You see here. Okay, I think I got the issue. So when you are putting this, no, don't put question mark. I think it's taking question mark also. Of course, we'll have to correct in our model. Then it will take from there. So let's go and see our database. Yes. It's getting only 3 records. I think query which is making is wrong. So if I ask for Alice and all, it will work. Of course, this can fix by using @ tools. But nevertheless, this is how we can integrate with Streamlit. Okay, so let it run. In meantime, we will go and see the next example. Next is a still more better example, which you will all like. So what is happening here is, so in this example, we are going to hit a URL, fetch the data from URL, and we will ask questions for that URL, correct? Yes, so that's what we are going to do. So it's a good example. So you see st.input text. This is my input text. So I will hit it, get questions from there and answer. So Let's first run the example to see how this works. So one more command prompt. Streamlit runs. Yeah, so see, process URL and fetching the data from this particular prompts. I think the only problem here is it's getting the first three records. So let me put the same question. So let's go and see this URL. Open link, copy link, just open it, hit it. So lang chain, yes. So let's go and ask, what is the use of lang chain? So this is what we are doing, correct? So it's getting data from here and showing that data. Now, since two models are running, it might take a couple of minutes. So while this runs, let me explain you the code. Okay. So at first, we, as usual, set the page config, title, and caption. We created the sidebar. In sidebar, we select box. We give them an option to select Llama 3 or Mistral. For embedded model, we are making use of Nomic embed text. Now here we are saying fetch web content. So we get whatever URL is passed, we get the data from that URL. We are using a library with name Beautiful Soup. So using this library, we can parse the HTML, correct? So what I do here is, if it contains script or style, we remove that, correct? Because script, anyone who knows HTML knows that you can inject something by using script, correct? Especially malicious code. Script can also be used for genuine code, but it can also be used for malicious one. So we are just removing that. And after removing that, whatever text comes, that text we are storing it in text, correct? Then what we are doing, we are making use of recursive character text splitter. So we are dividing this data, whatever we got from there, into docs, correct? We are splitting into documents. Then using Olama embedding and using FAISS, we are creating the vector store, correct? In vector store, we are saying k:3. So now what we are doing, we are creating the chat Olama model and we are creating the rack template saying that we are a documentation assistance and we are making use of the context, correct? Yes. And question with the user gave. Now just to improve the import to LLM, we are saying chat prompt dot from template. That will give me the template. Then by using the chaining, we give the context as retriever, question as runnable pass through. We give the rack prompt, Olama and str output, correct? And return this. Now what we do is we check if rack chain is not present in session, we initially make it null. Now in the h2.text input, we are given this value. Now when that button is clicked, we give a sprinter. We are calling the fetch web content. And if page text is present, we are adding that within the documents with the source URL. And we are calling this setup rack chain, which we just now discussed, correct? This function. So we set up that. And within rack chain, this same rack chain, we added within the session state because it's a heavy resource. So we added within the session state. And in the messages, we say role.assistant and st.rerun, correct? Then again, so if the session contains rack chain, and if you have messages in st.session, we are printing that message as a chat message, correct? And when st.chat, when user post a question, that we take as a user and prompt, and st.chat message we use, correct? So write prompt we do, and with st.chat messages as assistant, we are doing spinner. We are calling the rack chain dot invoke. Whatever answer we are getting, we are printing the final answer, and also adding it in st.messages, correct? So whatever result will come, that will be shown. So if I go here, it's still running. Both are still running. I think I ran two models. I should have waited for one of them to complete. So Lama is also running. I go and see logs. Still running. When it runs, it will get the result. It will not only get the data from the context, it will also show the result. Same applies here. I think we should have waited for one of the models to get completed. What I will do is just go and just delete one of them. We can just run this. We can close. Let it run. Let's see. So again, this is slow because I am running the Olama model on my machine, on my local machine. Had I not run it on local machine, it would have been faster, correct? See, it gave the answer. Able to see that, everyone? Yes. Okay, so this is how we are able to. So you see, The advantage of Streamlit still lies in the fact that it's very easy to integrate with agentic AI like applications, correct? Quite easy. It provides widgets, it provides support to easily connect with these agents. This is what the support is, correct? So that's how we are able to run this. So hopefully that makes that complete Streamlit. Yes, complete. Now let's start with ChromaDB. Okay. So ChromaDB for agentic AI, we will have a overview, use cases. We'll compare it with FAISS. So what is ChromaDB? ChromaDB is a open source embedded database. The major use of ChromaDB is designed for LLM apps, agents, and RAG pipelines. It has inbuilt support for metadata filtering and high-level operations. It provides local persistence backed by cloud-based vector store. You can store the data in cloud also. Correct. So provides open source embedding as well as it provides support to use the same thing in cloud. Okay. So why ChromaDB? Naturally, the answer to this question is we want agentic AI or agents to be faster. So fast retrieval process should be there. It should allow semantic search with embeddings, correct? It should support multi-agent memory structures, correct? More than one agent can connect and should be able to store. It can be easily integrated with Python and any model provider, correct? Now here in our example, we are using Olama, correct? And finally, we also have real-time updates for dynamic agent. So updates can also be applied. So the basic unit of ChromaDB is collections. Okay. So this collection stores embedded documents and metadata. Then we can have embedding functions like OpenAI functions, Olama, and custom. So these are the functions which allows embedding. Then we can have persistent storage. We can store the data in Parquet file or SQLite. And the query engines which are available are also similar to SQLite or Parquet. Right? So this is what it provides. Agreed. So we have collections. Okay. So this is how it works. Now, one question which comes in mind, what is the difference between FAISS and ChromaDB, correct? So FAISS is Facebook AI similarity search. We have used this earlier. It's a high performance vector search library, correct? It is optimized for large data sets. It supports GPU. So, not necessarily CPU, GPU acceleration can be used. Okay, it is not a database layer. Please remember that. It can search very fast. It can handle big data set. Yes, big positive point. But it cannot act like a data store. So if you want a data store, the most preferred choice in the agentic AI world is ChromaDB, correct? So we'll go for ChromaDB only. Is one of the preferred choices, correct? But if you want similarity search, yes, you can make use of FAISS. So ChromaDB, you see full vector database. It allows metadata filtering. Very important point. Persistence out of box, easy for agents and REG. If I say FISS, it's fast, low level vector indexing. No metadata or persistence, best for huge data sets, correct? Huge vector sets. And requires, if you want to achieve database functionality, then you will have to write your own wrapper. Okay. Now question comes, when to use what? You can use ChromaDB when you need metadata search, when you want persistence. You will use FAISS when you want to speed up massive scale and you can manage metadata and storage externally, correct? Now, how will be the flow in Agentic AI with ChromaDB integration, correct? So agent generates a message converted to embeddings, okay, and they are stored in Chroma collection. Similar past context are retrieved. So when a question comes, it will first query ChromaDB to find any similar experiences already there, and agent decides the next action, correct? Okay. So that's how the flow happens. So let's go and see how a simple chromatic database works, correct? So we'll start with a simple example, then expand our example further. So, yeah, chroma one. Sorry, before that, this. So from ChromaDB, so this will just make you understand what it is doing, correct? So the basic unit in ChromaDB is a collection. So from ChromaDB, we import client, we create the client object, and we create a collection and call that collection as agent memory. Then we have using an embed function, which gives a text. So in embedding, we have nomic embed text, and whatever prompt user enters, that we pass and convert that to embedding, correct? So this is basically a helper function to return embedding of a particular text. So you remember embedding is numerical conversion of a text to vectors, correct? Yes. Numerical values. So next what we are doing, we are adding a message agent observing user intent. In the collection.add, I'm passing the documents in which I am passing this message. In the embeddings, I am saying embed of message and ID equals 1, correct? And then I am asking a question, what did the agent observe? And what I will do next is collection.query. I make use of the query embedding in which I embed the query and I check for top 3 results, correct? And whatever results will come, that results I print. So see, this example shows you the basic units of ChromaDB. Collection, embeddings, storage of embeddings, and collection query on the collection, correct? So if I run it, not much will happen, but nevertheless, it will make the flow clear, correct? So let me clear Python. Yes, you see, whatever retrieved, it showed, correct? All the metadatas. Yes. So this is how this ChromaDB works. So it shows a historical data where we can look up. So we can use query. And that query will get the historical context and how much results we said, that results it will show, correct? So using this basic example, let's make it more optimized for our use case, correct? So what we are doing here is we can now directly use this will give a warning, we can replace it later on. Yes. So what we do is we have a documents. The document contains page content and we have Olama embeddings with model as nomic embed text. Now we make use of chroma.from documents I pass the documents, I pass the embeddings, I gave a collection name, correct, and I give a directory where I want to store this. So till the time the directory is present and it's not corrupt, we will be able to access, correct. So this is what we told, persistence is provided out of box in the case of Chroma. Then what we are doing is, we are using VectorDB as a retriever. Number of results is 2. I create the object of chart Olama and I am giving you are a project assistant. Answer the query only based upon following context, correct? So I give the context and the question. Using from template, we are optimizing this rack template, rack prompt, and creating a rack chain. So context is retriever, ChromaDB. Question is runnable pass-through, correct? So whatever user enters, that will come here. This is followed by a rack prompt, and this is followed by LLM, and this is followed by string output parser, correct? So if you see here, when did the development of Atlas project begin? Answer we are waiting, rack chain.invoke, correct? So if I go and see this, Atlas project started in Q3, correct? So it should be able to select that from the context and answer. So if I run this, these are warnings that will go away if I import it from LangChain. See, everything it gave as the answer. You're able to see from Olama. Yes. What we will do just to avoid this. Yes. Just to avoid that warnings. Yes. If you run this again, the warning will go away, correct? Just to show you. See, the answer came correctly. So this is how this ChromaDB works, correct? See there. You see that ChromaDB structure also got created. So here in the persistent DB, what is the name I gave? ChromaDB basic. See, ChromaDB basic got created from the folder where I run. Yes, you can see it got created at 2037. Yes, so this is how this works. Hopefully that makes sense, everyone. So let me explain the code again. So if you see, I have some documents using Olama embedding. I am creating the embedding of these documents. Then I am using VectorDB as retriever. I'm saying chat Olama, giving context and question. Context will be this vector store. This will be the question, correct? So when I ask the question, React chain dot invoke query, correct? So it will search this query. First, it will check the context, then React prompt, correct? And then it will apply on the LLM, and whatever output comes from there, that output I will show, correct? So this is how the ChromaDB flow is. Okay, so let's try. So now let's try to use this on a full scale application, correct? Yes. So this is a full scale application with agent. Okay, so I am using the model as Mistral, embedding as Nomic embedding. Okay. Chroma we are taking from LangChain Chroma. And we are using chat prompts and documents, correct? So in the create mock, I'm creating a simple content where we give this remote work stipend message as well as paid time of message, correct? Then what we are doing, we are creating a file in the path, correct, internal document, and whatever path was passed, and this content we are putting, correct? Now next function which we have is setup ChromaDB. So ChromaDB checks if ChromaDB exists, DB path exists, this path, correct? Chroma underscore DB path exists. If it doesn't, if it exists, is remove that, clear the old database. Then using recursive text splitter based upon the data passes, it divides the data on chunk size of 500, correct? And chunk overlap of 100. Then what we do is in the docs chunk, we say text splitter dot split documents. We are splitting that documents. And then as usual, we will make use of Olama embedding. And this Chroma will get the documents, Chroma dot from documents, correct? So document chunks, Olama embeddings, and ChromaDB. And we will create the vector store. So then we query the RAG agent. So here we have chat Olama, give the Olama model, chat prompt dot from message, and create stuff documents chain. We are calling this create stuff document chain method, and create, and we are using the vector store as a retriever. So this create document chain actually takes LLM and prompt and it takes a retriever document, correct? And stuffs it into the context. Then in the retriever, we are making use of vector store.as retriever and saying search is equals to 3. And we are creating the retrieval chain. Then we say retrieval chain dot invoke input and question, correct? And whatever answer comes, using this retriever and document chain, that answer I print. And we are also showing document.page content. So based upon the response dot get context, we are displaying the page number from where it's showing, correct? So now what we are doing, we are creating the mock data. We are opening the file, reading the doc content. We are creating the documents. We are setting up ChromaDB. We are querying RAG agent. How many PTO days are, and what is the rule, and what is the CEO's favorite color, correct? And finally, we are removing this. So if I run this example, it's running. Let's wait for a minute. We'll have to run the 3 questions. See the answers you can see. First question, when will be the stipend paid, correct? Also showing the top 3 chunks from where it picked up the data. The second question is running. Second question also answered. Third question. The third question is processing. Yes, you see, it gave answers perfectly, correct? This is how this example works. So I'll explain this example again. So we created a mock document. Then we set up ChromaDB. So what does ChromaDB do? It goes over the documents which you have passed, splits the documents, does embedding, and stores them in vector store, correct? Then we developed a RAG agent which makes use of question and the vector store. It takes the question, makes use of the LLM, and make use of chat prompt template, uses this chain in, correct? So we will require the chain in of LLM and prompt, as well as retriever. Retriever is the context, correct? And the integration of all these three happens here. Create retrieval chain. You could have also done by the earlier way we did, but this is also an alternate way, correct? And then retrieval dot invoke input and question, correct? And whatever question final comes as the answer, that answer we give along with the corresponding documents from where it was retrieved, correct? Okay, and create mock document, we read the contents, we create documents, we set up the ChromaDB store, and we query RAG agents, correct? And for each query, it made use of the vector store and answered, correct? So this is the way ChromaDB works. Yes. So we will extend this example of ChromaDB to read various README files, correct? So in internet, in GitHub, okay, this URL, copy it. Go for row. In fact, we can use everything from this. This looks quite good. Change log, readme.md, again raw. This is not plain. So we want plain text. Otherwise, we'll have to convert all of them. So let's go to license.txt. Okay, so these two URLs I use. So what I will do is, I want to download these two and create a ChromaDB and fire questions based upon this. Let me also see whether we have better readmes. Let's say React dot oh yeah, readme. Yes, let me take this also. So we have taken 2, 3 URLs, correct? So what I'm going to do is I'm going to write a code. Copy this ChromaDB example. Rename web ChromaDB. Let's name this as web ChromaDB. So instead of creating mock data, we'll download. We'll make a dictionary. WebDict here for web page, comma content in WebDict dot items. Okay, I will make use of the request module. Data equals this is URL content. In fact, I don't have to. We just can just download. Just download. So we can say content equals request dot get URL dot text. It's a store in ChromaDB. Okay. For each of these pages, we'll download that and we will make use of this. I have to create documents, so I'll come down documents. Come here and copy this. Documents. You can say documents dot append round bracket. And here we will say content. Content And instead of source, source, we can say web page. Web page. That's it. Correct. So we'll keep on applying these documents and return these documents. Return documents. Okay. So instead of saying store in ChromaDB, let's say make documents from URL. Okay. Now then set up ChromaDB, which is fine. Olama model, this is also fine, correct? This all remains same. Now, here, this all is not required. This is also not required. This will get converted to, so it will create URL dictionary. Webdict equals curly bracket. We'll have to give some name. Content 1, comma, chain log 1, comma, content 2, content 3. Okay, and we will call make documents from URL and pass this webdict. Okay. Whatever documents come, that will be make in the web store. Set up ChromaDB store is same, correct? Yes, so you just check if it's present, it will remove, else create. Okay, then what we will do? Then we will query. So let's query based upon our README. So just open the README again. Let's say what are the changes in what are the changes in V 1.1.1. Okay, this was question number 1. Question number 2. What are the feature highlights of React Markdown? Okay, and third question is what is CEO's favorite color? That we can keep same. We can run it, correct? So document mock path, I don't think is required. That's it. So I think this will get the data. So it's always better to log. So we can put print. Downloaded. Okay. And Remaining things are fine. Yes. Okay, so let's try running this. Let's copy. Python. When we run this, it will download from all of that GitHub repos, create the ChromaDB, create the context. And will make the data available, correct? So it's running. It's wait for the results. So you see, we can download anything and have it already kept in ChromaDB so that we can directly go for the questions, correct? And answers. Hmm. Yeah, see, not bad, isn't it? Version 1.1. Fixed back top alignment, revert changes, correct? Not bad at all. And it also showed the chunk. Now we are going to the second question. In which we are trying to get the features of React Markdown. So second question is also running. See, it gave all the features. Yes. Features of Mac, and it's related the chunks, correct? Quite impressive, correct? And it's asking the third question, CEO's favorite color. Of course, it will reject this question. So you see, setting up ChromaDB and using it is very straightforward, correct? And you can see it answers all types of questions which we want, correct? That's the biggest advantage of using ChromaDB. It provides a persistence layer. Now, in our examples, we were deleting everything, but in real world, we will not delete everything, correct? Every time when ChromaDB comes. Yes. Okay, so any information about CEO's favorite color. So you see, it's so easy to make use of ChromaDB. Okay, so again in this example, I will explain this example again. What we did was we made documents from URL. So we made use of the request module, which will make documents. The documents were then passed to ChromaDB. Now here we actually delete if ChromaDB already present, but in real world we will not do that. And we made use of Olama embeddings, correct? And create a vector store from there. This vector store will be used in the context. Then we say query rag agent. Then we'll pass chat Olama, chat prompt template from messages and create stuff and create retrieval. So this create stuff documents is to link LLM and prompt. To link the retriever vector store and the prompt, we made use of create retrieval chain. These are all helper methods which are provided, correct? So these are all helper methods which are provided by LangChain Classic module. So you can also go for the older way, like the earlier example which we did, where we made use of the pipe operator, correct, to create the expression language. Choice is up to you. So there are two different ways of doing the same thing. Which one you want to use is up to you, and then we invoke. And you can see it gives the response. So after retrieving the data from Chroma, it actually massages the data by using the models, and that result it shows along with the top three context from where it picked up the data, correct? So this is what we use to actually download the data and fire up the queries. Okay, so let's recap what all we did today as such. So first we started with uh, Streamlit UI integration. We saw chat message of HT. We also were able to see how to pass a message and how to wait for a response, correct? And how can we display the response on the UI, correct? So for displaying the result on the UI, once it comes back from the agent, we made use of the Streamlit context handler, correct? So if you go and see this uh, example which we did today, we clearly made use of that Streamlit. Yes, we made use of the Streamlit callback handler, correct? To get the callback from the agent and display it. This callback is passed as a callbacks keyword or a key whenever we use invoke, correct? Then we went further and extend this example to support web. Then we slowly went towards Chroma. So we started learning what is Chroma database, how it supports embedding, how it supports filtering, correct? And how it is able to do semantic search. That is very important, correct? It's not exact search. If you have worked with any SQL like Oracle, MySQL, SQL Server, you will know it searches for exact search. Here, if you see, it goes for semantic search, correct? Now, easily integrates with Python and Olama, real-time updates for dynamic agent memory, correct? All this is quite easy. And then we went for ChromaDB architecture, how it can persist. Then we went for FAISS. What is the difference between FAISS and ChromaDB? So here we learned that FAISS also supports similarity search, but it can support huge data sets, but it doesn't provide a full-fledged DB facility, correct, which ChromaDB provides. So you'll have to build DB layer on top of it, correct, or metadata layer, which is fully supported in ChromaDB, correct. So it provides metadata search, it provides persistent agent memory, and it also supports agentic RAG applications, correct. And then we integrated agentic AI with ChromaDB, and we saw how to use it, correct. Yes. So instead of query, now if you see, had we used ChromaDB to actually query instead of creating the SQL agent and getting the data from there, had we used it directly to query the results from MySQL and create a store and use that store, it would have been quite easy, correct? To get the data streamlined, isn't it? So that's the advantage of using ChromaDB. Search will be faster. It will be quite easy to retrieve the results, correct? So this is what we had for the day. Hopefully you all enjoyed the session. So we are coming to a nearly closure of all the topics which we had to do. Tomorrow again we will see some miscellaneous topics, and I think we did quite a good number of hands-on example, and one hands-on example as such to complete this session is what we will see in coming up days. Okay. So thank you everyone. Hopefully you all enjoyed the session. We will again catch up tomorrow to learn something new. Thank you. Yes.